Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And in studio with us we have Mark. And Mark, if somebody needed to contact us, what would they need to do?
For math homework help, in Bakersfield, call 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Mark, where do you go to school and what grade are you in?
I go to Reagan Elementary and I'm in 5th grade.
How is 5th grade?
Easy. And
It's easy?
It's mostly easy and it's pretty good.
It's pretty good.
All
All right,
easy
so
to mostly easy.
what, is there anything at all that you don't like about it or you would change if you could?
Probably not, actually.
You like to keep everything easy?
Yeah.
That's a nice way to keep everything easy?
Yeah.
Well, guess what? We're going to make things not so easy today, all right? Because that's how you develop your brain and you grow and you learn more, right? Mm-hmm. When you get challenged with something, right, it makes it a little tougher, right? You're like, oh, I got to think about that, right? So everything gets going in your brain and you develop your brain and you learn something else, right? Mm-hmm. Are you ready to do that today?
Yes.
All right, good. What have you been doing in class recently as far as your math class?
Multiplying fractions.
Multiplying fractions. And you feel pretty good with fractions?
Yes.
All right. So you've obviously added and subtracted them, and now you're multiplying them.
Yes.
Have you gotten to divide fractions yet?
Yes.
Okay, so you feel pretty good with that? Have you done decimals and percents?
I've done decimals, but not percentages yet.
All right, so we'll work on a little bit of that today too, because that's another big part of 5th grade is fractions, decimals, and percents. All right? But before we get to any of that, let's first take a look at today's Math in the News. All right, so there's a name of a company up on the screen. You know that company?
Amazon.
Amazon. You ever heard of them before?
Yes.
What do?
You order something online and they give it to you in a package.
It's pretty easy, isn't it?
Yeah.
You like that, right? Make things nice and easy? All right. Well, this was a headline today. Amazon is raising base salary cap to $350,000 from $160,000. That's a pretty big jump, isn't it?
Yeah.
That's not just for your average employee, though, okay? So they employ, how many people do you think work for Amazon over the entire globe?
Probably like 50,000.
50,000? That's a good number, right? Well, they buzzed it already.
guess.
He's saying, no, that's not it
On
already,
X,
right?
man.
1.6 million people.
Whoa.
Whoa is right. Okay? That's how many people work for Amazon. All right? So those are people that are paid hourly and office staff that earn salaries. Right? So you know the difference between somebody that earns a salary and somebody that gets paid by the hour? What do you know about that? Can you explain that a little bit?
Well,
Or give me an example or something?
a salary is like what they get over a month, but per hour is what adds up to get a salary.
There you go. Okay. Yeah, you're on the right track, right? So a salary, so let's say you work for salary, and the company gives you $1,000 for a month, all right? And I work by the hour, and I get paid $10 an hour, okay? Now, in order to work and get $1,000, if I'm getting paid $10 an hour, how many hours would I have to work? 10 times what would give me 1,000?
I was actually thinking about this the other day, and I think it was 100.
Yeah, exactly right. All right, so I would have to work 100 hours during the month to get $1,000. You are going to get your $1,000 for the month, but you have to work 100 hours. No.
No.
You work whatever you want, right? As
Yeah.
long as you keep everybody happy that's paying you. Could you work 200 hours during the month? Could you?
Probably.
Yeah, you could, right? So you could do more than 100 hours like me. Could you do less than 100 hours?
Yeah.
Yeah. All right, so you could work 10 hours and you're still going to get your $1,000, right? So that's how that works in a quick little way like that, all right? So Amazon pays workers, how much, so let's say you're going to get paid by the hour. Do you have any idea what they pay a person per hour? Not a salaried person, just a regular person. Your first day on the job, they go, come on in, you're going to go to work and you're going to start getting orders and filling orders for us from the warehouse.
$11 per hour.
So they get at least $15 an hour, and they're going to move them up to $18 an hour. All right, so that's a pretty good wage for just an hourly worker right there. Okay. So investors have been watching Amazon's rising cost. And have you ever heard of Amazon Prime?
Yeah.
What do you think that is, or do you know what it is?
It's the movie one.
Yeah, it's where you can watch movies and things like that, and then you get special advantages when you order things and stuff like that also. So a Prime subscription is being increased by $20. So as soon as people heard that, the shares of stock raised 14%, right? And went up to over $3,000 per share. So in order to buy one share of stock, you have to pay over $3,000 just to have one little piece of Amazon, all right? So that brings us to the headline again today, all right? That was the news of this, and let's talk about the math behind here. And there's a lot of things we could do, but we're just going to do a reasoning and come up with a percent of increase, okay? So what was the old salary for an Amazon person here that they say? So look on the screen. What was the old salary?
160,000.
Right. So let's just make it 160. Let's forget the other zeros. Right? Let's just say it was 160.
Yes.
The new salary would be what?
Um,
So if it went from 160, what's it going to? It's going to go to 350,000, right?
Yeah.
Okay. So how many times do you think, now let's just take all the zeros off. So now we just have 35 and 16. How many times can 16 go into 35?
Twice.
Twice, with a little bit left over, right?
Yes.
Okay. So if I said, here's $16, and I give you another $16, did I give you a whole amount of the first one?
Yes.
Okay, so that's 100% if I gave you the whole thing, right? I doubled it, right? So you're making 100% back, okay? So if we extend it at 32 and we're going to get to 35, how many are left over?
3.
3. And 3 is about what part of 16?
4.
It's about 4, maybe 5 times, right?
Yeah.
Based on if you're going by 5s or 4s, right?
Oh, yeah.
Okay, so let's say it's 4, all right? So in order to get from 32 to 35, you need to go up 3 more, or about a fourth of it, right? A fourth of a whole thing is what? So if a whole thing is 100%, what's a fourth of it?
25%.
25%. So if we already went up 100%, and we're going to add another 25% on that, how much percent did we increase?
125%.
We increased 125%. Okay? So if you could ever get a job where your salary increase is 125% like that, you've got yourself quite a career. Does that make sense a little bit?
Yes.
All right, so we just kind of did that mentally right there. But if you went from 160 to 170, that would be pretty good too, wouldn't it?
Yeah.
But that was a big increase. And not everybody gets that once again, but that was simply the headline that came out today. That is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. This is our 20th season on Do the Math. And today, Mark, a 5th grade student from Reagan, is here to help celebrate that 20th season. And Devin, have we spoken about this before, but how did you get involved with Do the Math? How did you hear about it or get involved with the show?
So I used to teach 6th grade at Voorhees Elementary here in Bakersfield with Bakersfield City School District. It was my first teaching job. And I had been attending some trainings, and people had started to know my background working in broadcasting and media. And so they heard that I had this background. And during one of our trainings, I believe it was Hilda Wright who mentioned, you'd be a good fit for the Do the Math program, her and Barbara Parr
Right.
both together. So
that's how you found out about it. And how long have you been with the program now? Do you remember when you came on?
It would have been back in 2013, 2014, thereabouts. So we're talking about 8 years now.
All right, great.
Yeah.
Well, it's been a pleasure having you, and I'm glad that Hilda
Wait,
and
is this my
Barb
last
were
show?
like, hey,
Is this it?
why don't you come on? You don't have your walking papers yet, son. You've got an hour to work here still right now today. I know that. There you go. Give him that. Anyway, I'm glad you brought up 6th grade because even though Mark is in 5th grade, he's got a 6th grade math problem that he brought in today. So let's go ahead and take a look at this.
Tremendous.
So Wendy earned $14 per hour. She don't work for Amazon, does she?
Well, not in
Okay,
California.
you'd be getting 18 bucks an hour. So she earns $14 an hour for X hours plus a bonus of $50. Write an expression that represents what Wendy earned. So Mark kind of has an idea on this, Devin, but he's not sure exactly how to write the expression for it. So why don't you two go together and see if you can figure out an expression for this problem.
Tremendous. So let's go ahead and bring up the problem again on screen just so we can reference that. Let's think about this situation from an hour perspective. So Wendy earns $14 an hour. On top of that, she's going to get a bonus of $50. So just off the top of your head, if we don't know, well, let's work about this. Let's say we know how many hours she works, right? Okay, throw out any number of hours, just anything that can be friendly or easy to work with.
5.
5, okay. So let's think about if she works 5 hours. How would we figure out how much money she makes in total?
Well, you have to divide 5 divided by 14.
Well, let's put it to you this way. If she works 1 hour,
Yeah,
how much does she make for that 1 hour?
14.
All right, so that would be 14. And how did you figure that out? It's just 1 hour, it's just 1/14, right? So it's essentially just 14 times 1. Now, there's also a bonus, isn't there, right?
Yes,
How much is the bonus?
$50.
So what do we do with that $50?
We add it to the 14.
We're going to add it to the 14, right? Okay. Now, let's go ahead and let's say she works for 2 hours, okay? How would we figure out how much money she would make in total without actually figuring it out quite yet? How would we figure that out? Similar to if she worked 1 hour.
Well,
So let's say 2 hours.
we multiply 15 times 2,
Is it 15 by 2?
or 14 by 2,
Okay.
and then add 100 because that's 50
Well,
double.
is she getting double the bonus? Or does the bonus stay the same just on top of how many hours she works?
Well,
But you know what? That's a good point, right? Because if we
'Cause
take
now
a
all
look
of a
at the
sudden
way
it's
written,
not
plus a
$14
bonus
an
of
hour.
$50 altogether, or a
Right.
bonus of $50 per. Let's just say it's $50 altogether.
Just tell you
That's
what.
your one-time bonus.
We're getting $50 per hour bonus. I want to talk about this $64 per hour job here. Okay, let's negotiate. Let's get into this business. But when we talk about a bonus, it's usually just on top of everything she's collected after the hours. So it would be just an additional 50 on top of the 14 times the 2, right? Okay, great. Now you mentioned we don't have to actually calculate this or figure this out yet. We just need to express it as an expression. Now let's go back to the 5 that you mentioned. How would we figure out how much money she would make in 5 hours.
You multiply 14 times 5,
Okay?
and then add 50.
Great. Now, here's the thing. Going back to the original problem here, we don't know how many hours she worked. How do we know that we don't know? If we look at the original problem here. How do we know we don't know how many hours she worked?
Because instead of a number, it gives us a variable.
It gave us a variable. It gave us x as that variable. So she worked x hours. We don't know how many hours x represents, but we know it's some number. So with that, following the pattern here that we've built, how could we write this down as an expression?
Well, since we know that every time we multiply the amount of hours by 14 and then add 50, it'd be 14 times x plus 50.
14x plus 50. So we have two terms here, and each of these terms represents something different. The 14x represents the amount she makes just on the hourly rate of $14 per hour. However many hours x is, we'll multiply that by 14. Then we have the bonus here that we're adding to that, 50. Now, based off of what you know about addition, some of the properties, might there be a second way that we could write the same expression so it still accounts for the same total?
50 plus 14x.
50 plus 14x. So both of these represent the same total of what Wendy here would earn based on that hourly rate. Tremendous job, Mark.
There you go. Nicely done. So you've got the expressions part out of the way right there. So once you get comfortable with expressions, and you'll be doing a lot of them in 6th grade as well as 7th and 8th grade, you move on to equations. But before we do that, let's do another expression. All right? So clear the board, and I've got one for you. All right? So we're going to open up a set of parentheses, and you're going to put negative 6n,
Negative 6.
negative 6n, minus 8. Okay, now on the outside of the parentheses, put plus 3. Open up another set of parentheses, 2n minus 5. Close the parentheses, and now let's take care of this expression.
So in this case, what we're looking to do is basically simplify all of these terms so it's easier to make sense of. There are a lot of properties in place here. So have you interacted with any of this before?
Yes.
Okay, I want to see how you would approach this.
Well, the numbers that have like the same variables go together, and the numbers that don't have a variable go together.
Okay. What can you tell me about this situation that we've got over here with the 3 parentheses 2n minus 5?
Well, since the number is next to the parenthesis, we know that that's multiplied. And since 6 here has n and 2 here has an n next to it, I know that these two go together.
So go ahead and start working that out for us here as far as how you'd figure this out on the board. So I can kind of see what you're talking about here, but I want to make sure that our viewers at home are clear what's happening with this term. Okay, so I'm going to pause right here. It looks like we're trying to combine the terms within the parentheses first. Now, the reason I wanted to draw your attention to the 3 next to the parentheses is that there's something done with this value when it's directly next to this term. So for example, very similar to what we had before. When we were looking at 14 times 2, we represented it like this, where the number was directly next to the parentheses. So we kind of understand that this represents multiplication here.
Yes.
So do we have the same thing happening up here?
Yes.
Now, how do we multiply 3 times 2n minus 5?
Well, since my answer was negative 13, I'm multiplying 3 times negative 13.
Let me go ahead and put this over here to the side just for a moment. And I want to make sure we have a chance to get back to that in a little bit. So what we're essentially saying here, when we say we have 3 2n minus 5s, is we have this, 2n minus 5, 2n minus 5, 2n minus 5. And so we know that we can also represent multiplication as repeated addition, correct? So if we can say 3 times 2, what we're really saying is 2 plus 2 plus 2. We're adding 2 3 times.
So that's 6.
So this is 6n. You're right, 6n, because we're doing the same thing here. We have 2n, 4n, 6n. Now what's going on here with these minus 5s or negative 5s?
Well, it's actually not subtraction because they're all negative.
So we're adding negative values.
Yes.
Some might argue that adding negative values is the same as subtracting positive values. And that's, a conversation about the language of mathematics. But how do we combine, if we're going to be adding these 3 negative values, where would that get us?
Negative 15.
Negative 15, so minus 15. So let's do this. Let's go ahead and re-represent 3 2n minus 5 as this, 6n minus 15. Now let's talk about negative 6n minus 8. Do we still need these parentheses here, do you think?
Probably not.
Okay, so let me just go ahead and bring that out of the parentheses here. Now we have negative 6n minus 8 plus 6n minus 15. You mentioned that you would approach this by combining all of the like terms together.
Yes.
Do you see like terms at this point?
Yes.
Okay, so how would you combine the like terms here?
Well, this is a negative and this is a positive. So we know that this will equal 0, so we don't put that in our answer.
So those terms, because they have the same absolute value but different signs, will zero each other out.
Yeah.
Absolutely. So that leaves us with what then?
Negative 8 and negative 15.
So how do we work with negative 8 and negative 15 to combine those values?
Since they're both negative, we add them. And negative 8 minus 15 is negative 23.
And I thought that was interesting how you almost accidentally expressed it in a similar way, how you said negative 8 plus negative 15. And I think that you can approach that the same too. So I think that was really insightful. So after we simplify this entire expression, the n terms don't even factor in. What we're left with is negative 23.
There you go, nicely done. So you feel comfortable with expressions now.
Yes.
Perfect. Let's move on to your first equation. All right, clear the board. And since you said everything in 5th grade is easy, we'll make this an easy equation. How about that? All right, let's go. Up on the board, let's go ahead and write this. 7x equals 5, open parentheses, x minus 12, close parentheses, and now you want to solve for the x. So this is going to be what you did first with getting rid of the parentheses, and then you're going to have a couple other steps to go to. All right?
So let's go ahead and focus on this. Now, last time it was kind of easy to lay it out when we had 3 parentheses 2 and minus 5, because we could just do that in order and just add those terms all together. But like we said, there's a relationship between addition and multiplication, correct? So what we essentially did, I mean, the long version of doing that, was we multiplied that 3 into both of those terms, correct?
Mm-hmm.
So let's talk about how we could do this here. How do you think that might apply to this term after the equal sign?
Well, I know that this has to equal this, or these two have to be like, I can't get it.
Well, I think you're in the right spot as far as having similar values in regards to that equal sign, right? Anytime we think of an equation, we think about it like a balance, where whatever is on this side has to be the same as whatever's on this side, right? It has to have the same mass, the same values, right?
Yes.
So we want to make sure that after we work this out, that both of these have the same value. So let's figure out what this is actually related to, and then we'll make that comparison to see how we can figure that out. So 5 parentheses x minus 12. How could we simplify this side based off of our work with something similar in the last problem we have? Just this side here. Let's just focus on 5 parentheses x minus 12.
Well, 5 and 12 go together because they both don't have a variable.
Now, when you say go together, what do you mean?
Like, since this is negative 12 and 5, they go in one equation as 5 minus 12, which
Okay.
equals negative 7.
So let me bring this back over here and just reflect on how we dealt with this term from the last time, right? As we added those three 2n minus 5s together, it represented multiplication as a way that we can do this a little bit more quickly. So let's see if we can do the same strategy here with our 5 parentheses x minus 12. 5 times x would equal what?
We
don't know, right? It's just 5 times x. So
Yeah.
we can just represent that as 5x. Now let's look at this net minus 12 component. We think of that as negative 12 in this context. 5 times negative 12.
Negative 6.
Negative 60. Great. So let's see if I can move. Well, I can't move all of that here. Let me go ahead and just pivot here. We'll bring 7x down. So we know that 7x now equals 5x minus 60. So what that means is if I have 7 of something, it's equal to 5 of something minus 60. Now, in order to figure out what x equals, generally, I want it to stand on its own. So when something's on a balance, you can bring it over to the other side, right? Take a look at this 5x term. Could we do the same thing here?
Yes.
Okay? How might we do that? Because if you take something off a scale, you don't have a balance anymore. So you have to take the same amount off the other side, right?
Yes.
What could we take off of both of these sides and still maintain some balance?
X.
We could take an x off, right? In fact, let me do this. Let me create a new space here. I want you to think about it like this. I want you to think about each of these boxes being an x, right?
Mm-hmm.
So on this side, I have 7 x's. And let's say this is on a scale, right?
Yes.
Okay. I want both sides of this scale to weigh the same amount. Now on this side of the scale, I've got 5 x's. And I also have another box that weighs 60. Technically negative 60, but that's a whole metaphysical issue of negative weight. We won't worry about that, right? But I know that this is negative 60 of something. Okay. What can I take off of both of these so that I still have the same weight on these scales?
Well, probably need to take. Actually,
Because remember, if you take something off of one side, in order to make sure that there's balance, you have to take the same thing off the other side, right?
side, yes.
So what can we take off just as a start?
Probably 2 x's.
I'm going to take 2 of these x's off? Great. Let's take 2 of these x's off. Okay? We had 7x here. We had 5x minus 60. Now, we took 2x off. we took 2x off. We're now at 5x. And over here, we took 2x off, and we're at 3x minus 60. What else can we take off and still keep the same weight balance?
Probably.
Can we take something else off of both of these?
I don't think you can actually take something off.
Well, we took 2 off,
Yeah.
and they're still the same
Yes.
balance, right? They're still the same weight. Are there any more x's that we could take off to maintain the same weight? Like if I take off one more, can I take one more off of both sides? Because I have one more on both sides, right?
Yeah.
Do I have 2 more on both sides?
Yes.
Do I have 3 more on both sides?
Yes.
Do I have 4 more on both sides?
No.
Okay, so I can take 3 more off of both sides and still have the same weight on both sides. So let's do that. Because that'll leave me with 2x up here.
Yes.
And I'll take 3 off here. And now all that's left is this negative 60. So let's talk about what this means. 2x equals negative 60. But we're not trying to find out how much 2x equals, because we already know that. We're trying to find out how much x equals. So
You have to divide 60 divided by 2.
we're going to divide 60 by 2. No, negative 60 by 2. When I divide negative 60 by 2, what does that mean?
Negative 30?
X equals negative 30. Now, let's check to make sure that that's the right value here. We said that x is negative 30.
Yes.
So let's go ahead and make sure that x equals negative 30 here. And if it does, and if we're accurate, both of the sides of the equation should have the same value. So we have 7 times negative 30.
Yes.
What would that equal?
210. Negative 210.
Negative 210. Great. So 5 parentheses negative 30 times minus 12 should also equal 200, negative 210, correct?
Yes.
So now it's easier to work with a value in the parentheses because we can just combine these values here, right? Within the
Yes.
parentheses. So negative 30 minus 12.
Negative 42.
Negative 42. And just for the sake of time, I'm going to go ahead and multiply negative 42 times 5. And we can break this up. We know that 40 times 5 is 200. And 2 times 5 is 10. We have a positive and a negative after we combine this. So that is 200. So this is negative 210. So right on the money, x equals negative 30. Equations, there's a lot of bounds to play around with.
Yeah, there's a lot there, and I love the way you guys approached that problem and took what Mark knew and what he was thinking of and then went from there. So nicely done. So for some great work so far this afternoon, Mark, you've got yourself a meal courtesy of our friends at the Broken Gill Cafe, so congratulations on that. All right, so Mark, if somebody says to you, I want to go to the yard, or I want to get a yard, what does that mean to you? What do you think of first when somebody says the word yard?
Like a backyard?
Like a backyard. All right, well, that's one of the things we might find out in today's language of mathematics.
The language of mathematics. What does it mean in English? What does it mean in math? Today's word, yard. What does that make you think of? Well, if you have a house, you probably have a yard. Heck, you might even have a yard sale, right? You've seen those before, where you put a bunch of stuff in the middle of your yard trying to get rid of it, which is kind of an odd concept in itself. But however, it just seems to me like most of the time we think of yard, trees and grass and plants, and heck, if you're not a very good yard keeper, then maybe you have a little bit of dirt back there as well. Working hard in the yard. So in English, we think a little bit about maybe back part of a house. Maybe, if you're like me, you thought of football, right? How many yards someone gained in a game. Maybe you think of construction. We'll talk about that in just a little bit. The reason is because you can order certain types of equipment or certain types of commodities in yards or even in cubic yards. However, in math, we're going to look specifically today at a unit of length, right? This measures length equal to 3 feet or 36 inches. Either one. Both of them the same, just a different way of doing it. So where do we see a yard? Hey, there's your feet right there. There you go, right? 1 inch, about the knuckles worth of your finger. You got a foot. Not everyone's foot is exactly a foot, but if you had 3 of them that were exactly a foot, you'd have a yard. Maybe you think about football. Here's a couple examples that might make it a little bit more clear. So if you are converting something from big to small, in other words, if you want to go from 1 yard, which is a big measurement, to the number of feet, which is a little bit smaller measurement, you're going to multiply. So in all these examples we're going to look at initially, you're going to multiply. Here's the first one. 2 yards, 6 feet, 72 inches. And the way we get that, 2 times 3 is 6, because there's 3 feet in the yard. And 2 times 36 is 72. What do you think might come next? How about 3 yards? Yeah. Think about that for a second. How would you get the number of feet and the number of inches? Well, we're still multiplying here because we're going from something big to something small. So 36 times 3, and then 3 times 3 is 9, and that's where those numbers come from, 9 and 108. Should we try one more? How about 10? 10 yards, how many feet in that one? 10 times 3 is 30. 10 times 36, 360. So that's one way you can convert. What if you're going the other way though? What if you have a bunch of little units, little small units, and you want to go back to yards? Well, we can do that as well. This guy's pretty excited about that. If you're going the opposite direction from small to big, you have to divide. That's all there's necessary. So in this example, 9 feet is 3 yards. So 9 divided by 3 is 3. How about 18 feet? Think about that one for a minute. 18 divided by 3, that'll give you 6. That's where that one comes from. What if we want to go from yards to inches? Yeah, we did this one here. 108 inches is 3 yards, so we're dividing not by 3 this time, but by 36, because remember there's 36 inches in a yard. So what if we have 180 inches? 180, I know you can do this in your head. 180 divided by 36? 5, everyone said it together, well done, nice job. That's exactly how you do it. You're gonna go backwards on that one. So, hey look, there's 3 feet in the yard. They're all different colors too. Where are we gonna use this? That's always the question. We have all these definitions, but we gotta know where we're gonna use it. So, if you're a football fan, like I said, you're gonna know how many inches. You can do that real quick in your head. If someone has a 4-yard gain, times 36, wow someone in your audience next time and tell them how many inches they gained on that play. If you are a landscaper, I mentioned this earlier, you can order bark or dirt or soil or even grass by the cubic yard, okay? And an estimation. The reason I put that up there is because we really want to know if something is a certain distance away. You can estimate that in feet or yards, depending on how far it is away. All kinds of places to use this stuff. And that's why it's important to know the language of mathematics. Today's word, yard.
Language of mathematics, Scott right there, and yard. And as Mark said, when he thinks of yard, he thinks of backyard. And Scott was referring to things that you'd use in the backyard using cubic yards and things like that. We do have phone tutors available on most Tuesdays and Wednesdays throughout the regular school year until 5:30 in the afternoon. Right now, we are fortunate to have from Panama Buena Vista Union School District, Kelly in with us from the music department. And Kelly, what will you be doing today?
Well, first, Mr. Cushine, I wanted to send a message to you from Gavin and Samuel. They said hello. They were in Gate last year.
All right.
And so they wanted to say hi.
Oh, good.
And we're going to talk about commutative property. And I was going to see if I could actually spell it. Let's see, without looking too much chicken scratchy.
There you go. You got 100 on that right there.
I got it? Okay. Property. Okay, there we go. And commutative property is when you add something. So give me a couple numbers. What do you want? Something easy.
5 and 3.
5 plus 3. And what does that equal?
8.
That's okay, good. We like that. But if I did 3 plus 5, the answer is really
Still 8.
it's still 8, isn't it? Okay, so addition, you can do this. Multiplication, you can do it. You can do 2 times 3, let's say. What's that?
6.
6. And then we can do 3 times 2, and it really is
6.
It's still 6. So math is all numbers, and it's kind of dry. But what if I told you that you could feel commutative property in a piece of music? Well, I don't know. Would that feel good or wouldn't it? Well, let's see. So if we're playing a song, there's a piece from Leonard Bernstein, West Side Story, called America, and in it, it does just that. Oh, I'm gonna sing it for you. Hold on. Okay. Da 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 da. And what he's doing is he's switching the accents and the emphasis, and he's going 1, 2, 3, 1, 2, 3, 1, 2, 3. But it's longer here. But it's still going 1, 2, 3. So if you have goodbye numbers. Okay. If you have, you read music, Mark.
Yes.
So to you, this looks normal. Let's do it. Let's just do it with the 2. Do, 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 boop, boop. So those are what kind of notes? Chicken scratches. Those are
Half notes?
eighth notes.
Oh,
So we're going to count those 1 and 2 and 3 and that's all there is to it. If you were going to count and clap those, you would go 1 and 2 and 3 and, right?
Mm-hmm.
Well, if we changed it a little bit and kept the 1 and 2 and 3 and, we could put, it's still going to be 1 and 2 and 3 and, but what if we change the bars like this, boop, and this? We still have 1 and 2 and 3 and, don't we?
Yes.
So it's still the same thing, but it might sound different. So if you were thinking America, da 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 da, and it changes because of where that bar is. It's all written super easy, but it doesn't. We're still going to have 1 and 2 and 3 and no matter what. And I don't know if I explained that very well, but it's pretty cool. It would be more cool if I could play the music for you. But, so we can do 1 and 2 and 3 and. Da 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 da. He actually changes, Bernstein, the composer, he does it in 3/4, which you would know. 3 beats in measure, quarter note gets the count.
Yes.
And on a score that the conductor would see. They would see that, which is really weird. But it's because it goes between 3, 4, and 6, which we would have 6/8 notes. 1, 2, 3, 4, 5, 6. Look at that, okay? And in 3/4, guess what? How many eighth notes would we have?
6.
Yeah, we would. We're just barring it differently. So that's what's happening. He's using the commutative property and just changing the way we see it. But it's like 2 plus 3 or 3 plus 5, 5 plus 3. It's still going to come out the same.
Yes.
I know that was amazing, wasn't it?
Yes.
So that's what I've got for you.
There you go. Nicely
That's
done.
putting math, and the cool thing about that is you can hear it and feel it, right?
Yes.
Da, 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 da. And you can actually feel that pulse. So,
And that's a pretty big example that you're using, because I remember that from when I was young, West Side Story being out on Broadway, and then that is also something new right now. If I'm not mistaken, I think that
Yes.
is being nominated for some awards this
well,
year.
I think they've made a new movie of it.
Right.
So the original one was with Natalie Wood, who wasn't a singer. I think they got singers this time. But
Okay.
if you listen to that and hear that, that's about the Puerto Rican people saying, oh, I want to live in America, and they're
Right.
telling the good things and bad things. And it has this 6/8, 3/4 feel, and it's going to come out the same. It's 2 plus 3 or 3 plus 2.
There you go. So
Commutative
nicely
property.
done. Thanks for coming in today, Willey, once again with the Panama Buena Vista Union School District and the music department. And who knows, maybe Mark will be able to see that movie, and then he'll be, oh yeah, now I remember the song that Kelly was singing to me, kind of humming that along, and it'll all come rushing back to
That
me.
would be cool.
So nicely done.
Nice
Thanks
to
for
see you,
that.
Mark.
We do have phone tutors available until 5:30 this afternoon. We'll be back with more right after this.
The Royal Mail ship Titanic was thought to be unsinkable. But on April 14, 1912, during her maiden voyage, Titanic struck an iceberg in the North Atlantic. On that fateful day, the world lost the largest and most advanced passenger steamship of her time. Marine explorer Dr. Robert Ballard first located the wreckage in 1985. Nearly 20 years later, he returned with a team of researchers to map the wreckage and conduct scientific analyses of its deterioration. Remotely operated vehicles were used to conduct a look, don't touch mission, which is extremely important in respecting and protecting this memorial. Fitted with high-definition cameras, the ROVs were able to stay in one spot long enough to reveal subtle features never seen before. Here we see Captain Smith's cabin. The side of the cabin has deteriorated and fallen away, and we plainly see the bathtub, pipes, and faucets. This large hole is at the base of the ship's forward smokestack, which is ripped off as the ship sank to the bottom. The ship wreckage is now covered by what look like rusty icicles, called rusticles. These formations are actually communities of bacteria that slowly eat away at the ship's iron and give the shipwreck its melting appearance. A comparison of rusticle growth over time helps scientists to better understand Titanic's degradation as well as that of other metal shipwrecks. The story of Titanic's sinking and her ill-fated passengers have been famously told in films and books. But Titanic lives on at the bottom of the ocean as a maritime memorial and as a scientific laboratory.
More than 2.5 miles below the surface, the wreckage of the Titanic rests on the seafloor, both as a memorial and a living laboratory. 100 years ago, the world's most advanced passenger steamship struck an iceberg. On April 15, 1912, it sank, losing 1,496 lives. The legend of the Titanic was larger than her size, and finding the wreck site opened a door to not only exploration and scientific study, but to salvage as well. With ties to multiple nations, steps needed to be taken to preserve and protect the integrity of the wreck site. For the U.S., NOAA and the State Department negotiated an international agreement with representatives of the UK, Canada, and France. This agreement recognizes the wreck site as a memorial to those who died and a wreck of great archaeological, historical, and cultural importance. The agreement set rules for research, exploration, and salvage. The memory of the Titanic lives on in movies, books, and museums, but it's the protection of the wreck site that will continue to yield clues about the fateful ship and its passengers.
All right, so before we get to the Titanic and things like that, let me ask you, Mark, did that make sense to you over there, the commutative property with Kelly and how you guys were doing that math over there?
Yes.
And so you play violin and piano, correct?
Yes.
And so how long have you been with those instruments?
For piano, about like 5 to 6 years. For violin, I just started in September last year.
All right, so which one came into your mind more, or did both of them as you were going through that example with Kelly? Did one instrument come into play a little more in your head when you're thinking, yeah, this is kind of how I do it?
Yes, more of the piano.
More of the piano?
Yeah.
And probably because you've been playing that for a longer amount of time too, right? And that kind of stuff, it seems like it would make more sense with the piano than with the violin.
Yes.
All right, well, now what we just witnessed on here, the Titanic, right? You familiar with the Titanic?
Yes.
I think just about everybody is, right? I mean, it's a pretty famous cruiser. And how far down do you think the Titanic is where it is set on the ocean floor?
About probably 200, 300 miles away from where it first sailed.
Right. And how far down do you think it is?
500 feet
Yeah,
down.
well, it's more than that probably, right?
Yes.
And we think of the Titanic as resting on the ocean floor, right? And we think that that's going to be pretty deep.
Yeah.
That's not even halfway to the furthest point at the bottom of the ocean. There's still even deeper parts, and that's not even halfway down where the Titanic is, right? Because we're able to get to that pretty easily. But then we're talking about pressure and things like that, but we won't get into all that today. Because we want stuff that's pretty easy, right?
Yes.
All right, well, let's continue with the easy stuff for Mark today. So let's take a look at another one of the problems that you brought in. Ivan started the week on page 35 of his book and read 20 pages every night. What page will Ivan be on if he reads for 8 nights? And then they want to know for 12 nights. So explain to Devin how you would like to take a look at this problem. Solve it.
First, I want to know what kind of book this is that you just get to start on page 35. I feel like there's some important things that you're going to be missing as far as story and content, but that's not me.
Maybe he started before, but they're just talking
He might have
about-
already read it in the past. It's like, well, I'm
Yeah.
going to do this all over again. Gotcha. All right. Makes sense. Let's figure this out. How would you
Well-
start with this?
He reads 20 pages every night, and they want to figure out how many pages he'll read for 8 nights.
Well, I think more specifically, let's look at that question again. What page will Ivan be on if he reads for 8 nights? So not necessarily just how many pages, but what page in the book he'll be on after reading those additional pages each night.
Well, what you need to do is multiply 20 times 8 and then add that to 35.
So that's really interesting. So it seems like in your head you've got one of those expressions that we worked on earlier before, right? How would we write this situation out as an expression so that no matter how many nights he reads, we can figure out what page he's on?
Well, for 8 nights, you put 20 times 8 plus 35.
So if we calculate this out, what part of this would we do first? The 20 times 8, the 8 plus 35, how would we start?
Well, according to order of operations, multiplication comes first before addition.
Great, so let's go ahead and multiply 20 times 8. And then we'll throw in the 35 on top of that. So we have 160 and we'll add 35. So what this represents is the page number that Ivan will be on after night 8. Now let's take a look at the second part of that problem. What else do we have to figure out?
12 nights.
12 nights.
All right, Mark? How would we figure that out?
It's exact same thing, except
That's a fancy too. Very elegant. All right. So we're going to do, it sounds like we're going to be doing something very similar, except we're going to swap out the 8 for a 12. Is that right?
yes.
Okay.
So the expression would be 20 times 12 plus 35.
Now there's a couple of ways that you can approach this, right? Like you can do the multiplication of 20 times 12 and then add the 35. Or you could also recognize that we can take the 195 and we can throw 4 more nights of reading on top of that, right?
Yeah.
Because how many pages would he have read in the difference between 8 and 12 nights?
4.
4. So how many pages would he read in 4 nights?
Well, that 80.
80, right? So we could add 80 to 195, or we can multiply out and add 35. Either way, we should get to the same point, right?
Yes.
So go ahead and work that out.
I'm going to start with the adding.
to get us to page 275. So if we think this is a bigger, longer book with a lot of pages that are going to take a lot of nights to read, we can build an expression to tell us what page number he'll be on at the end of each night. It would be 20, and then if we don't know the number of nights, what could we put in there instead?
Variable.
What variable would you like to use?
X.
You want to use that? You can use any letter. That's the nice thing about variables. It could literally be anything.
Anything.
So we can use X. We could use N for nights. That
Yeah.
could be very helpful. Let's do that. Let's do N for nights. And then, what do we add to this number of nights?
35.
35. Now, think back to our conversation about the commutative property and the expression we had at the very beginning. Is this the only way to represent the page number that we'd end up in?
Yes. Or, I mean, if you already have solved another number, you could just add the difference.
Yeah, you can do that.
Yeah.
Could we start off, since we're starting at page 35, could we start off with 35 in this expression?
Yes.
And then what would we add to that?
20n.
20n. So the commutative property still applies. In fact, if you think back to here, when we added 80 pages, and basically 4 more nights to get to 12, we're essentially treating this like 8 plus 4 to get to our 20 times 12. And if you think about how we can multiply that 20 to the 8 and the 20 to the 4 and add those together, 160 plus 80, this is another property, the distributive property that we've talked about a lot this afternoon when it comes to parentheses. So a lot in play here to get us all to these same points. So at the end of 8 nights, he'd be at page 195. And at the end of 12 nights, he'd be at page 275. Oh, there's so many great things about these problems we've been working on today.
All right, clear it. Here we
Wow,
go.
great things.
So one more problem. I'm going to give you guys 1 minute. Here we go. James is 5 feet 4 inches tall. So put 5 feet 4 inches up on the board somewhere. And we need to know how many inches that is. And you have 1 minute.
I'm going to let you go ahead and take the reins on this one, Mark. Go for it. How many inches tall is he? You threw that right up there. How did you get to 64?
Well, I know that there are 12 inches in 1 foot, so I just multiplied 5 times 12, which is 60, and then added 4 inches.
So essentially, you can take 12 times the number of feet and then add 4 if you don't know how many feet tall it is.
Yeah.
But that's how you just plug in 5 for the feet to get to 60 plus 4, 64 inches.
There you go. Nicely done. So Mark, you did some great work today. Did you learn a little something?
Yes.
Good. And was it all easy?
Well, one of the questions.
Yeah, we challenged you a little bit, right?
Yeah.
So that's good. That helped develop your brain and help you grow a little bit right there. Did you have some fun today?
Yes.
Good. Glad to hear that as well. We do have phone tutors available until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.